All right, last time we started section 14.1, and in particular we took a look at translations, rotations, and we just started looking at tessellations. So let me jump back in with you to tessellations. So if you remember, tessellations are a shape that fills the plane with no overlaps and no gaps. Some shapes are actually regular tessellations. They're regular polygons that are actually able to tessellate. And what we discussed and where we ended last time is there's actually only 3 that do that are regular tessellating shapes. One's a triangle, specifically an equilateral triangle. The second one is a square, right? 4 sides, 4 angles, all equal. And then the third one is a hexagon. And we kind of worked through how to think about and why it is that none of the others work. So I stopped with hexagon, but we could continue the process much like we did for pentagon to see that none of the other ones work as well. We would find the interior angle of, say, a decagon, and we would find out its whatever degrees, and we would attempt to take 360 divided by that, and we would find a problem. It doesn't divide evenly and give me a whole number. Now, that doesn't mean that these are the only 3 shapes that tessellate. You guys have seen tiling in all kinds of shapes before that are not regular shapes. Remember, regular doesn't mean like normal or something like that. We sort of have that idea or that connotation with the word. Regular means all equal sides, all equal angles. So we can, in fact, tessellate with other shapes. So non-regular polygons can be used in tessellating as well. For any convex quadrilateral, okay, quadrilateral 4-sided shape, if you take half turns of the shape along one of the midpoints and you half turn it, see where I was, the shapes will fit together at a common vertex and can be used for tessellation. So this is kind of a funny diagram perhaps. You can see the original shape that's up there in black, like it's outlined in black. And here's the midpoint. And if you take a half turn around that midpoint, you're going to be down here in this shape. Okay? If you take a half turn around this midpoint on this line over here at point P, you're going to be over here at this shape. And then if you take a half turn either around the point right here or the point right here, you'll end up with the third shape in the bottom left-hand corner. And they fill the space, right? And the reason that that's happening, I can't remember if I have a slide on that or not. I don't think so. The reason that that's happening is because all 4 of these angles add up to what in a quadrilateral? 360. So what you actually see happening is all 4 of those angles meeting at this common vertex in the middle. So here's angle A. Angle B comes to here. Angle C at the top ends up over here, and angle D ends up right here. So just like the 4 angles within the quadrilateral added up to 360 degrees, when they are all placed together in the same location right here, they will also add up to 360 degrees. So half turns is one way to get a tessellating shape from a quadrilateral that is not regular. Let's look at another one. Another way to tessellate a plane with a non-regular shape is to take a polygon that tessellates like a square or a triangle and then cut a design out of one side. Okay, so what you see is this image here at the top. This was a square, and you see that they've cut a design. It's kind of dotted out the side, right? So they've got this really pretty sort of curving feature now going on, whatever it looks like that, something. I didn't trace it very well. Okay, so they've cut it. And as long as you have that same cut shape on both, in this case they did top and bottom, then the pieces again will fit together nicely. So what you're doing is you're taking a slide. Let me read the words that it actually says. So a polygon that tessellates, such as a square, you cut the design out of one side of the polygon and slide that design to the other side of the polygon. And then you fit the shapes together. Okay? So this is one that we see used very commonly in a lot of our tiling. Now that you guys are going to leave here like today and you're going to look at all the tiling around, you're going to be like, oh, look at that tiling. Oh, I know what they're doing. I know why that works. It's going to be really cool. It is going to be really cool. All right, here's a third one. Yet another way to tessellate the plane with a non-regular shape is to cut along half of a side of an equilateral triangle. So this one's specific to an equilateral triangle, just like this one was specific to a convex quadrilateral, okay? So you have to start this diagram picture, so to speak, with a triangle, an equilateral triangle. And you can see in blue over here what they've cut out, right? There's this blue shape that's cut out right here. And if you can imagine cutting it out and then rotating it a half turn so that it sticks on right here. So it's an indent here and it's an, I don't think outdent is a word, but that's what it looks like, right? It's poking out over here, same shape. And then you can see what's happening here is we have that shape down here in the bottom that's all in the blues, repeated over and over. And the corresponding shape up here is just a half turn of the other shape. It's the same shape, just a half turn of it. And we get the same image. You can do this on all three sides. So this one I just showed it on one side. They've only manipulated side CB. But you could manipulate all three sides to get more interesting tessellating shapes if you wished. Your book actually goes into some detail about how to make more intricate tessellations using rectangles or squares. Think mathematical art in the classroom. Many of you have been to my office, though not all of you. I have mathematical art, not tessellations, but I do have mathematical art in my office up on the walls. There's some lovely designs that come from tessellations. In particular, for inspiration on tessellations, M.C. Escher is known for his work with tessellations. This image you see on the screen right now is an M.C. Escher design. There is a fair warning in it's like the small print at the bottom of the slide. He has some dark work too. Might not be something you want in your classroom if you're, especially the younger the kids you work with. So just beware if you search M.C. Escher, and I don't mean like it's horribly awful or like violent or anything like that, but it's just maybe not uplifting kind of things, not colorful or whatever. But he does have some work that is colorful, and you can see this one's really cool. So you can kind of see what's going on. Definitely a shape that's tessellating. What does it look like? Fish, or sometimes people look at it and think it looks like birds. It just depends on my class. And so I'm going to go ahead and make this announcement now. This is it for this section. We're going to go ahead and do the group work here in just a minute. It's very short. But before we do, I want to talk to you about something that you're going to do for me later, and you will actually have an opportunity to think more about this. But I want to sort of put it on the forefront of your mind that it's coming so that you're aware. So we're going to actually talk about the fact that you're going to create a tessellation. So I want to show you, that's what I'm going to turn this screen off. I'm going to show you designs that have been created in the past from previous classes, assuming that I still have them in my iPad. Give me a sec.